Okay, so vectors day 2. We're going to find directional angles and we're going to find vector components. All right. So first of all, finding angles of direction. Okay. Yesterday we talked about like northeast, southwest. That's all fabulous and good. But what if you don't have that? What if you just have the x and the y component of your vector and you need the angle? So that's what we're looking at here. So using the component form of a vector. Okay, so you can find this angle using this relationship of tangent we know right here. We know inverse tangent is the y over the x, and that's going to give us theta if we do inverse tangent. So for instance, so angle of direction given this vector, so -5, 3. So the first thing, here's your little steps over here. The first thing you want to do is draw yourself a reference triangle in the correct quadrant. So think about it. Where are your x coordinates negative and your y coordinates positive? Hopefully you catch by now that's over here in quadrant 2. So x is -5, y is 3, right? And theta is in the corner. Okay, so put theta in your triangle. We did that. All right, use inverse tangent of, it's always y over x. Remember, opposite over adjacent. So that would be 3 over -5. That's going to give me my angle theta. Now, if you use your calculators, remember that's just second tangent. So when I get an answer for theta, my calculator gives me -30.96. Okay, if I round it to 2 decimals. Now, what you're going to do when you get your theta is throw out any negatives. We don't really care about the negatives because that's really just measuring this angle right here. We don't care if it's negative. But remember, you want to give the angle of direction. So think about where you are in your quadrants. You are in the northwest quadrant, right? So I know my answer is going to have north and west on it. But I need to find, remember, the angle has to come from the vertical. So really, this whole quadrant is 90 degrees worth of angle, isn't it? So if I know that this little bottom triangle is 30.96, then the remaining part of the angle is what my directional angle really is. So what does that mean? It means you're going to take 90. You're going to subtract the whatever angle they give you, minus 30.96, and that's going to tell you the directional angle. You just have to slap on there the north and the west. Okay, when I subtract, I get 59.04 degrees, and that represents the directional angle that goes from the y-axis down. And that's really what I wanted to be able to put north and west with it. So that's the direction of my angle. All right, so let's try another one. All right, let's try one all together. You got to find the component form first, the magnitude, and the angle. So it's putting all these skills together in one problem. So if the initial point is -4, 6, and the terminal point is 5, -9, write the component form of the vector. There's problem 1. Find the magnitude, problem 2, and then the angle of direction, problem 3. So component form of the vector, remember, it's always terminal minus initial. So let's do this. Terminal is 5 minus the initial, so minus and negative means +4. Terminal is -9 minus 6, so that would be a 9 and -15. Okay, so that's my component form. So let's think about this. The magnitude of this vector is going to be the square root of 9 squared plus -15 squared. 9 squared is 81 plus 225 is 306. And if I take the square root of that, I get 17.49. So that's my magnitude, 17.49. So there's problem 1, there's problem 2. Problem 3 is finding the angle. So remember our steps in finding angle. We've got to draw it in the right quadrant. Look, x is positive, y's are negative. So where does that happen? That's down here in quadrant 4. So here's theta. X was 9, y is -15. So theta is going to be the inverse tangent of y over x, right? So if I plug that in my calculator, again, I get a negative angle, but don't let that negative throw you off. At 59.04, okay? So throw out the negative, we don't care. But that's this angle right here with the horizontal. I want the angle with the vertical. So the way to get that is take 90 degrees and subtract the 59.04, and I get 30.96. Now, what direction is that? Well, hopefully you see that that's south and that's east. So I would say south 30.96 degrees east. Okay, there's my angle. All right, part B, finding component form. Now what happens though if they just give you the magnitude and the direction? They don't give you the initial and the terminal end. How are you going to find component form? Well, here's the formula you're going to use. Notice it's the magnitude, this is the magnitude, times the cosine of theta. All you've been given is theta and the magnitude, and the sine of theta. Now remember, cosine is your x and sine is your y's, right? So this should make a little bit of sense. So this is your formula where this is the magnitude given. Now remember, magnitude is like speed or it's a force. Read for those things in the problem. So look at this. An aircraft carrier travels at 100 miles per hour, that's my magnitude, with a bearing of 23 degrees southeast. Find its component vector. All right, now in order to do this, this is where I was saying bearing and directional angle are the same thing. I've got to take that directional angle and convert it to a standard angle, okay, before I can go any further. This theta right here has to be in standard form. So let me sketch this puppy out. Southeast is down here. 23 degrees is this angle right here, right? So if I want the standard form of that angle, I'm saying I want the angle that goes here and goes all the way around. So think about that. This axis is 270, right? So wouldn't I just take 270 and add 23 degrees? Sure. That would give me 293 degrees. That's that angle, theta, that I want to use in my problem. So now I can come back to the problem and fill in this formula. The magnitude is the 100. So I was going to say 100 times the cosine of my standard angle, 293, and the sine of 293. Okay, there you go. Now, all I do is multiply. So I'm going to put in my calculator, 100 times the cosine of 293. Of course, you want to make sure you're in degree mode. That gives me 39.07 for cosine. And then do 100 times the sine of 293. And I get 92.05. So there is my component form of the vector. Now, stop and think. Doesn't this make a little bit of sense? Think about what quadrant your angle is in. It's down in quadrant 4. Your x's are positive and your y's are negative down here, aren't they? Look at your x component. It's positive and your y component's negative. So it should make some sense. All right? All right, example 4. An arrow travels 250 miles per hour with a bearing of northwest 57 degrees. So here's northwest. 57 goes next to the y-axis, and we know that arrow is going 250 miles per hour. Then it says a wind, an eastern wind, is blowing at 14 miles per hour at an angle 34 degrees below the horizon. Okay, so we have a separate picture here. This one's the wind. This is the arrow. Well, eastern is this direction. Hopefully you know that. But then this new phrase, below the horizon. Well, hopefully you know horizon is the horizontal. If it's below the horizon, that 34 sits next to the horizon. It uses that verbiage, below the horizon. And it's going at 14 miles per hour. All right. Now, in order to do my component vectors, I need to first convert these angles to standard angles. So let's focus on arrow first. All right. So I'm going to figure out what angle starts here and ends right there. Well, I know quadrant 1 is 90 degrees, and then I go 57 degrees more. That gives me 147 degrees. That is the angle I need to use for the arrow. So to find my component form, I take my magnitude and I multiply it by the cosine of 147 and the sine of 147, and we'll compute that. I get negative 209.67 and then 136.16. So that's my answer for the arrow. This problem has two answers because it's asking for arrow and the wind. Now let's come over here in the wind. We need to convert this angle to a standard angle, an angle that starts here and ends right there. Okay, so look, the full circle is 360, right? And we're going to go 34 degrees short of that. So 360 minus 34 gives me 326. So then to do component form, I take my magnitude and I do the cosine of 326 times the sine of 326. All right, multiply that out. All right, so this is the component form for the wind's motion. All right, so this problem had two steps, two answers. No big deal. You got this.